So, all right, everyone, thank you for joining with us for day two of our 100 days of ML series. Now, let's see what is regularization. We saw what is overfitting and underfitting in the last lecture on our day one of 100 days of ML series. Now, today we'll see regularization and its techniques for this day. We'll see how regularization affects on the overfitting. Like, it is one of the ways to reduce the overfitting and making our models to be more generalized and to prevent overfitting. So regularization is a technique we use to reduce the model complexity and prevent overfitting by penalizing the large weights. And so it adds a penalty term to the loss function, and it discourages the model like from over relying on some specific features. Our goal is to have our model to be generalized, not overfitting or not underfitting stage. Next is what type of regularization that are there in our model. So we see there are two types of regularization. One is lasso. So lasso is nothing but it adds penalty to absolute value of the weights, where it can shrink some of the weights exactly to zero. Whereas in ridge, it adds the penalty to square of the weights, where it doesn't reduces to complete zero, but it like it allows magnitude of all weights, and it has been believed like all features are useful, but we want to prevent some single features from dominating the model, right? And we have some, if we want to use elastic, which is the hybrid approach, that is called elastic net. We use L1 and L2, both the type of regularization, and we use elastic net approach when it is the model is highly complex. Okay, it is highly correlated, and we cannot pick a single features from the group. All right. And what is dropout? So dropout is nothing but during our training, we have a random subset of neurons. We drop that and temporarily disable it. Okay. So this is a simple process. While we see each iteration trains a slightly different network architecture, and it forces network to learn from multiple independent pathways for some of the information. So it is like randomly disabling some nodes to effectively train on an ensemble exponential number of our smaller networks while leading to much more robust final model. Final summary for choosing our strategy would be L1, L2, elastic net or dropout should be all dependent on our model because it is the art, while we balance the complexity, and we need to choose which one is the right technique. That depends on our data structure and specific to our problems. We need to see the features in it as well, how features are related to each other. If it is not related that much, we use L1. If it is so much correlated, we might use elastic net approach, like which is the hybrid approach. We need to see whether we can use dropout and drop some neurons and try to train our model on different iteration of different networks. So I feel this is everything about your model, your data structure, how complex is your model is, and how correlated your features are. But majorly, elastic net approach works the best in almost all the models. So we should try first, and then we can use dropout as well. So that's it for the day two of our 100 days of ML series. Next, we'll look all types of machine learning techniques. We call it supervised, unsupervised, and reinforcement. So see you guys.